Welcome to Mr. Brandt's 5th grade everyday math review. In this video we're going over lesson 5.12, fraction multiplication number stories. And so I have rectangles shaded in with different fraction portions, and you can see that there is 3/4 of the rectangle is shaded in with this tannish color. Then of that 3/4, 2/3 is shaded in with this color. So we've been talking about how this represents a multiplication problem, and if we go back a step further, we could also think of this as being written as 2/3 of 3/4. And thinking it in terms of this way is going to help us when we go to write a multiplication number story. Now, using the picture here to help me think of a multiplication, to help me think of a multiplication number model, here's what I came up with. I was thinking about apple pie because I really like apple pie. So my wife sent 3/4 of an apple pie with me to school and told me I had to share it with my class. My class then ate 2/3 of what she sent. How much of the pie did they eat? Well, we know that they ate 2/3 of the 3/4. And so to find our answer, now we're going to take our 2/3 and we're going to multiply it by the 3/4. And we know we can multiply the numerators together. That would be 6. We can multiply the denominators together. That would be 12. So 2/3 of 3/4 is 6/12. We can come back up here to our picture to double check. So the numerators show us how many pieces are shaded in. So 1, 2, 3, 4, 5, 6. And that's shaded in with both of the colors. And then we're going to count how many total sections there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so it's confirmed 2/3 of 3/4 is the same as 2/3 times 3/4, which equals 6/12. Okay, for our next problem here, you can see I've got 5 rectangles, and each rectangle has 3/4 shaded in. So I can think of this in a number of different ways. I could think of 3/4 of 5. Okay, I could go 3/4 of 5. I could go 3/4 times 5, or because of the way that multiplication works, the turnaround rule, I could also go 5 times 3/4. 5 times 3/4. So let's check out a problem that I could come up with based on this information. And here we go. My student brought me 5 nerd ropes on the last day of school. Ned Forrester found out about the candy and ate 3/4 of each rope. How much did he eat in all? Now, I'm going to choose this particular one for this problem because I know that I can't get a whole number answer when I find a unit fraction. So if I start with the 5 times 3/4, I know that 3/4 is equal to 3 divided by 4. So now I can take this problem and rewrite it 5 times 3 divided by 4. 5 times 3 divided by 4. I'm going to pick an entirely different color here. So 5 times 3 is 15. And then I can do 15 divided by 4. And there's a couple of different ways I can write that. So I can go and turn this division problem and write it as a fraction, because fractions are division problems. So 15/4. I could also take this and turn it into a mixed number. And to do that, I have to divide. So 15 divided by 4. I know there are 3 groups of 4 in 15. 3 times 4 is 12. So I subtract and get 3. So my answer would be 3 remainder 4. Now, the quotient becomes the whole number. My remainder becomes the numerator. And then my denominator is going to be my divisor. So 3 3/4. So if I think back to my problem here, how much did Ned Forrester eat in all? Well, he ate 3 3/4 of those nerd ropes. Hopefully I got a golden boy out of it to make up for it, but we'll see. For the practice problem at the bottom, we're going to do an addition and a subtraction problem with decimals. And they have them written this way. And if you remember in previous videos, we've talked about how when you're adding decimals, you have to make sure your decimal points are lined up. So I'm going to rewrite these problems, making sure that I line up the decimal points. So 4.24, then 2.163. Again, my decimal points have to be lined up. Now I can go ahead and add that together. As I've done in previous examples, you don't have to do this, but you can put your 0 there and then go ahead and add. So 0 plus 3 is 3. I should say 0 thousandths plus 3 thousandths is 3 thousandths. 4 hundredths plus 6 hundredths is 10 hundredths. 1/10 plus 2 tenths is 3 tenths. Plus 1/10 is 4 tenths. Now I have my decimal point. 4 plus 2 is 6. So my answer is 6 403 thousandths. For our subtraction problem, we're going to do 5 76 hundredths, subtract 3 82 hundredths. Just like with addition, we have to line up the decimals first. So I'm going to rewrite it and making sure that I line up my decimal points. And for this particular problem, our numbers line up at the end when we line up our decimals. Now, one thing I forgot to do with the previous one is to estimate. So estimating, I always look at the greatest place. So in this case, both of them are in the ones place. So if I look to the right, the magic number is 5. So 7 is higher than 5. So the 5 would round up to a 6. Then we're going to look to the right here. 8 is also higher than 5. So the 3 rounds up to a 4. So now we're going to have 6 subtract 4. So our estimate's going to be about 2. Our estimate's going to be about 2. I'm going to carefully get rid of our orange here. And I'll fix that. And now let's go ahead and do our actual subtraction here. So 6 hundredths subtract 2 hundredths is 4 hundredths. I cannot subtract 8 hundredths from 7 hundredths. So I have to go to the ones place, and I'm going to take 1 from the ones place, and I'm going to add 10 tenths to the tens place. So just like when we're talking about taking 1 from the fractions, we're taking 1 from the whole number. 10 tenths is the same as 1, so that's why we put our 1 here to get 17 tenths. So 17 tenths subtract 9 tenths, 17 tenths subtract 8 tenths is 9 tenths. Put in my decimal point. 4 subtract 3 is 1. So I get my answer of 1 94 hundredths. Thanks for tuning in today. I hope you have a great afternoon and a great evening. Make sure you go outside and do some playing.